Hello ladies and gentlemen, it's Steven here and welcome to my GPU overclocking guide. Now in this video I want to explain what overclocking actually is, how you do it, and show you my results in the end. So this tutorial works for all cards and it doesn't matter if AMD or Nvidia, and works only on Windows. I mean the concept, it's basically the same on Linux too, but the tools we're going to use, they only work on Windows. So my GPU is the XFX R9 290X. I have two of them. Thanks to XFX for sponsoring them. Those cards, they are really great, and I'm not saying this because I've got them for free. So I actually play a lot of GTA, also Battlefield 4, and now I can run those games in 4K with high details, and that's absolutely no problem. Also get some nice FPS rate, so I like that card. The cooler could be better, so that double dissipation, it's basically you have two fans on the cooler, and this could be better. So they also run kind of hot, like 95 degrees maximum with a high overclock, and yeah, they're actually designed to run at that temperature, but also the fan then gets really loud, and with two of them, boom, yeah, it gets really loud. But well, I actually don't care because I have a headset while gaming. Just if you're recording, this sometimes sucks a little bit. But well, we're going to talk about that graphics card, yeah, a little bit more this week. But honestly, I have to say, really nice cards, and I'm so happy that I've got two of them in Crossfire. But well, what is overclocking actually? Now, overclocking refers to pushing your computer components harder and faster than the manufacturer designed them to go. So we're going to raise the clock, so the frequency in megahertz on the core and the memory, over the stock limits to gain additional performance. And well, how much can you get out? Now this depends on the card, 10, 15, 20%, not all cards are equal. So also same models, like I have two of those R9s and they don't overclock equal. So one of them actually has a lower clock which is stable, and the other one could go a little bit higher. But due to micro stuttering, I just run them at the same clock. Okay, so yeah, this really depends on your card, and some of those cards, they don't even overclock a little bit, then they get unstable because they're already running at their maximum, and it really depends on the card. So you cannot say, yeah, he overclocked it to 1100 on the core, I will do the same, but maybe it's not stable with your card. Alright, so the clock really, the clock you get in the end always depends on your personal card. So do you benefit from that? Yes, you do, and I see it even more now in 4K because you don't have such a high frame rate, but if you gain some additional FPS in 4K with high details, then this is really good. So warranty, can it break? Yes, for sure it could. It never happened to me, and I overclocked a lot of graphics cards, also in my notebook with modded BIOS and whatever. But well, what basically happens when you overclock the graphics card is it's first of all pulling more power from the power supply. So that is why you should have a good power supply. What I'm using is a 1000 watt power supply from Cooler Master. It's the CMV 1000, very nice quality, very efficient, 80 plus gold, and yeah, you just need that, because if your power supply is already running at the limit and you're going to overclock, then your power supply maybe can't supply more power to the system, but the system just needs more, and then it gets unstable and it will crash. So make sure you have a decent power supply. Never save money on the power supply. Save money on some components, like just buy less RAM or whatever, but always get yourself a good power supply, which is really important, and you have that for years. And I can definitely recommend the Cooler Master CMV 1000. Okay, that's regarding the power, but the heat comes with the more power, and yeah, you have to just spread the heat and get it out of your case, and you do that with the cooler. And the stock cooler as well, they're not that good on some cards. Also, if you have a multi-GPU system, the fans, they're very close together, and there is not such a good airflow anymore, and then they can get really hot. So make sure you know the limits of your card, check them out on AMD or Nvidia in the datasheet, and make sure your card is not going to run much higher or not even higher than that, because yeah, for sure heat can break or just lower the lifetime of a graphics card. And you see, that's the black overclocking edition, so I guess it really doesn't matter if you just overclock it, because it's made for overclocking from XFX. If you just buy a graphics card from a different supplier, maybe overclocking voids your warranty, so please make sure you check that out, guys. Okay, so what do you need for overclocking? Well, you need time, just get yourself a coffee, beer, just chill, guys. This is really no race, and you also need a good power supply, as I've pointed out. The reason is, as I've said before, that you just draw more power from the supply in the wall socket because you have more performance, which always means more power. Okay, so your power supply shouldn't run on limits. And then you also need some freeware tools, so you don't have to buy anything. It's basically just some free performance you can get out of your card. And all the downloads, they're down below in the box, so make sure you check it out. Okay guys, so basically I'm using here the R9 290X. So why am I using that? Because it's the Black OC edition. DD, double airflow, whatever, double dissipation. I mean, it's more marketing because you just have two fans. A lot of cards have two fans. MSI cards usually also have three, so triple fans. Not a friend of that at all, but honestly, just get yourself one with a decent cooler. Just check out some reviews. XFX not too bad, but they run quite hard. Okay, so also the cooling is really important. Then it comes with unlocked voltage. Now the voltage is something which could limit your overclock. If you don't know what the voltage is doing, then let me explain it maybe like this. You have a tuned car, and it has a motor which is, very powerful, like 600 PS. But you still can't get so much gasoline to the motor. So, for instance, the pump which pumps the gasoline is very weak. Then the motor will just throttle, not run it at its full potential. Also, it will just limit, stop running or whatever. And this can happen if you can't increase the voltage and you increase the clock too high. So you just increase the clock to a certain level where you can't go higher without getting an unstable system. And then you have to also just make the voltage higher. Sorry, let me say it like this. So just increase the voltage, and then the system gets stable. And we're going to talk about this when we do the overclocking, so you can see how it really works, because it doesn't make sense to explain it right now. But you see, if you have unlocked voltage, then you also have a higher overclocking potential, and you can just tweak it a bit more to get a stable system. So that's pretty important. Also, this card, for instance, is fully compatible with PowerTune 2.0, so real-time performance optimization. Okay, so that's regarding my system, so you know what we're dealing with. And now let's just directly go to the computer. Let's check out the power consumption of the computer right now without overclock. Then let's overclock, and then I will just tell you my damn results. So let's go, guys. Okay guys, so we're now here in the game in Battlefield 4, and I just want to quickly show you the power consumption when it's not overclocked. So I just have loaded up the standard profile, standard clock. The CPU is not overclocked, everything is actually standard, and if we play Battlefield 4 in 4K with high details, you see I'm draining here 670 watts from the power socket. So, well, when we overclock it, I'm pretty sure we'll go over 800 or even more. And if you then also start overclocking the CPU, you get up to 850, maybe even 900. And well, you see, for overclocking you need a good power supply. So make sure your power supply is not running at the limit. Because, for instance, if you have a 600 watt power supply and you would get that amount here, then it will maybe be able to run it for a short time, but then it would get hot and then overheat and then just shut down. Then you think, well, the overclock is too high, but actually your power supply is limiting, but you could overclock higher. Okay guys, so now in the menus actually it should drop then, but well, that's my current power consumption, not overclocked, playing Battlefield 4 in 4K with high details. Then we will now overclock, and after the overclock you will see some benchmarks, and then we'll talk about the power consumption again to see how much we're actually wasting to get out 10-15% more performance in the game. So let's just go to the computer and let's do the overclock. Alright guys, so there we go, we're now here on the computer, and now let me quickly show you what tools you need to overclock your graphics card. So well, the download link for all that is down below in the description, most of the tools freeware, and you can just check them out and download them. The main overclocking tool we're going to use, it's MSI Afterburner, and you can see it right over here. It's a GPU overclocking tool made by MSI, but that doesn't mean that you need to have an MSI card, so it works with all kind of manufacturers, and it doesn't matter if you have AMD or NVIDIA, so it works with all cards. For sure you can use every other overclocking tool, so basically the basics are the same, but I would suggest to use MSI Afterburner because it's very powerful, you can do a lot, but other tools are, for instance, NVIDIA Inspector, N-Tune, River-Tune, or whatever. Then here we have some benchmarking tools. MSI Combustor, it's also made by MSI, but it's not working on my system, probably because of Windows 8 and the multi-GPU configuration, I don't know. But as benchmarking tool, so main GPU stressor, I'm going to use Firmark. Link is also down below. So we just check with that if we can see some artifacts, if the overclock is stable or not. Next thing, 3DMark demo, so we'll just check that out. So if we have gained some additional performance on the whole system, because this benchmarks basically the whole system. Then here, Heaven Benchmark 4.0, it's another benchmarking application from Unigine. Okay, then one of the most important tools, it's GPU Set, and download link also down below. It's also freeware, and we use that to monitor the clock, the temperature, and also the fan speed if you want to. Okay, here's some games, because after the overclock we're going to play a little bit and we're going to check out if it's stable and if we have gained some additional performance. Then let's just open up HardwareBot. Now it's really important to know your stock clock and the limits. And with that I mean, you should get an idea how high you could overclock with your current cooling system. And to check that out, it's pretty good to visit hardwarebot.org, link down below. And here just search for your graphics card. So you enter here the model number, and then I just found AMD Radeon R9 290X. And people are just posting the results they have got on overclocking. And you can just see here the stock clock, so the default clock. It's 1000 on the core, the first number is always the core. And the second one here is the memory, so 1250. Actually you can multiply that because it's double data rate RAM, but we're just talking about the base clock, which is here 1250. And here you can also see average overclock, and that's on air cooling. If you have water cooling, you can see that's probably something you can achieve. Then here you have cascade, and here you have liquid nitrogen. But if you have water, liquid nitrogen, you would probably don't watch this simple overclocking tutorial. Okay, so we check out the average overclock on air, which is 1143 on the core and 1549 on the memory. And this is actually something I cannot achieve because my system gets very hot. I have a silent case, intakes are closed, and I will definitely switch to water cooling because I can only overclock to 1115, 1500. That's actually my maximum I can achieve. And if I go below that, if I go further, so if I increase it higher than that, then my system just slows down because due to thermal throttling. Okay, that's basically it. So just note down those numbers, and now you have an idea how high you can overclock. Okay, now the next thing we should do is we should just enter our driver software, like here the AMD Catalyst Control Center or NVIDIA, the NVIDIA System Manager, whatever. So you just right click the desktop and you go to AMD Catalyst Control Center or your NVIDIA system thing there. And AMD comes with some integrated overclocking feature. It's called AMD Overdrive. NVIDIA has something similar. I think it's N-Tune or System ESA tools or whatever. I just remember that from my old NVIDIA card, but I don't have any NVIDIA card here to show you that. Just make sure that you deactivate the integrated overclocking feature. So make sure this box enable graphics overdrive is not ticked. This has one simple reason. We're going to set something MSI Afterburner, and this could mess up with the settings applied here in AMD Overdrive. Not on all cards, but on some of them, so just make sure you deactivate that feature. It's a noob overclocking feature and you don't want to use that. But it explains overclocking pretty good, so let's have a quick look at it. Now here you can switch between the GPUs. If you have more of them, make sure you just select the GPU you want to modify, and on Crossfire systems, for instance, or multi-GPU systems, you have one master card, and also so that's the main card and some other cards which are calculating. And you can basically overclock them separately, which I don't prefer, so I actually just synchronize the clock because this leads to less micro stuttering. then here you can see a chart which describes overclocking pretty good. On the y-axis we have the GPU clock, so that's actually the performance axis, and here we have another thing which is called the power limit. Now if you want to get more out of your card, you need to increase the clock, so make it run faster on a higher clock, so more megahertz. Now you can do that by just going here up on the y-axis, but when you just increase the clock, your card also needs to drain more power, because yeah, it's just putting out more power. And that's why you have to increase the power limit too, otherwise it cannot achieve the GPU clock and it will just throttle down. The power limit, it's basically the limit which your graphics card can draw from the power supply. For instance, if your graphics card is designed to draw 150 watts and you increase the power limit by 50%, then your graphics card can actually just now draw from the power socket, from the power supply 225 if I'm right, so 50% more. And yeah, that's really important, because otherwise you will just not achieve the GPU clock. Now you're somewhere here in this quarter if you overclock. So what does that mean actually? Now that means that your graphics card is now overclocked, has more performance, but it's also putting out more heat, so we're in that red quarter. And more heat also means you need to cool that, so your fans will spin up. That's why we have here enable manual fan control if you want to do that. So that's, for instance, on 100, it's very loud. And yeah, we don't want to do that, so we're actually using a temperature profile in MSI Afterburner. You could also underclock your graphics card if you, for instance, don't want to use all the power, if you're just doing some simple things like Microsoft Word or whatever, and you just want to consume less energy. That's possible too. But well, as I've said, we're not going to use that feature, but basically that chart basically describes overclocking really good. Okay, let's close that and let's have a look at MSI Afterburner, and make sure you run that application as administrator and just wait for it to load up. Now by default it looks kind of different, so let me quickly switch that. Here the user interface, so it will look like this, and there we go. And yeah, I don't like that skin because it's hard to see some things like the voltage, and yeah, I just don't like that because you don't really see all the things so easy. And that's why we go here to settings and we can switch the skin here. If you want to, you can also switch it, but you can for sure also use the default skin. We'll now switch to the MSI Cyborg skin. It's that one here, and I think it looks kind of nice. Now if you're from the USA, you can also switch here between the temperature format like Celsius and degree Fahrenheit. I prefer Celsius because I'm from Europe, and you can also switch the language here, but I will keep it now in English. Okay, so this is basically how my main skin looks here. And first of all, we should configure MSI Afterburner, because by default you cannot adjust so many things. So you enter here the settings by just clicking the gear, and then you're in the MSI Afterburner properties. Here, first of all, you can switch between your GPUs, and if you have a multi-GPU system, I would highly recommend to tick the box synchronize settings for similar GPUs, because you could get more performance out of your system if you just overclock them separately. But different clock on the cards usually also increases microstuttering, which I don't really like, so I just synchronize my GPUs. Okay, under compatibility properties, make sure you tick everything. So basically this just unlocks all the options like core voltage, but only if it's supported by your card. If you have some noob card where you cannot even set the voltage, well, then you can't do it, and you can just overclock as high as your stock voltage goes. Okay, then here we have AMD compatibility properties. So here we have extend official overclocking limits. Yeah, make sure you tick that, and disable that if you have a multi-GPU system. You don't need to do that, and you don't even have to think about that if you just have a single card. So just leave that like it is, so in stock. Okay, MSI Afterburner now wants to reboot the PC, which I will do right now. So let me quickly reboot, and then let's talk about how to use MSI Afterburner. Alright guys, so we're now here back in MSI Afterburner, and before we really start to overclock our GPU, we should have a look at the fan speed curve. So let me show you what that is and why it's quite interesting. So make sure you enter the MSI Afterburner properties, and here you just go to fan, so that's the second tab, and here you tick the box enable user defined software automatic fan control. This will give you a chart. fan speed on the y-axis over temperature on the x-axis. And you see fan speed in percent, temperature in degrees Celsius or degree Fahrenheit, depends on your configuration. And setting up your own custom fan speed curve, it takes some time, but this can really improve the overall behavior of your system. So there are different areas in this chart. Like here, first of all, we have the idle area. Just imagine you're doing some homework, you're just in Microsoft Office, you're just checking the internet, you're watching a movie or whatever. You don't want that your PC is very noisy. So currently I have 40 degrees on my card, and yeah, I just want that as long as I don't go over 50 degrees, so which usually doesn't happen if I'm not in the game, that the fan speed is running at a very low level. So I just keep it on around 40% until the card reaches 50. Then the fan speed is increasing with the temperature. Now yeah, it depends on your card. Now 40% is not really hearable. So 40% with the XFX cooler is not so loud, and I just keep it on 40%. And this is usually when I'm here in Windows on the desktop doing some simple stuff. It won't reach more than 40-45 degrees. But as soon as I start gaming, it heats up immediately to 70-80 degrees. And when I overclock my card and play some heavy 3D games, I can reach 90-95 degrees. And this is kind of bad. So at 70 degrees, so over 70, I just want that the fans are spinning up to 100% and that they're constantly running at 100%. And this is because my case is actually kind of small. It's a silent case, the intakes are closed. And I will also switch to water cooling at the end of this month, because with air cooling and multi-GPUs in that small silent case, that's not really good. The cards, they're getting really hot. Then you start to play, they are overclocked, they're getting even hotter, and then you get the effect of thermal throttling. That means the card reaches over 90 degrees, and then the safety in the driver tells the card basically clock down, because we don't want that the card is getting too hot and gets burned. And at 90 degrees, so the card is going to clock down to 300 megahertz just for 2 or 3 seconds to go down like 6 or 7 degrees. And this causes FPS drops in the games, and you can really notice that. So yeah, it really depends on which game you're playing, if your GPUs are running at 100%, but in the benchmark you will see that thermal throttling is really a pain in the ass. Okay, so that's my custom fan curve. Doesn't look really fancy, but it's doing a good job. Okay, so we now save that fan curve, and you really have to play around with that with whatever you're comfortable, because it depends on your card. Is it very loud at 40%? Is it really loud at 70%? I don't know, it depends on the cooling solution. But I'm really happy with that fan speed curve. So now just hit the OK button, and now the fan speed curve is saved. Okay, the fans are spinning up a little bit, and you can maybe hear it a little bit in the background. And now it's time to overclock our GPU. So as I've said before, the first thing we're going to start with is the core clock. And we checked out HardwareBot, so that website, and it told us people achieved 1140. Now, due to my bad cooling solution, it's actually not possible to overclock to that clock. So I will just go to 1115. From my experience with my system, I know that's actually safe. If you have never overclocked before, then you should just go in small steps up to the clock you want to achieve. Like raise it like 20 megahertz, then do a benchmark, then 20 megahertz again. But I already know that 1115 is quite okay. So now we apply the clock by just hitting the tick mark here. And now it's time to run a benchmark to see if this is really stable, because you don't see artifacts if your GPU is in idle, so it must be stressed and get a little bit hot. So yeah, to test our GPU, we run the benchmark tool firmark and GPU set. So running both is really a good way to just monitor your whole GPU. Okay, so first of all, let me explain GPU set. It's very simple. Here we have the graphics card tab, and here you can see your GPU clock. The core should run at 1115, and the memory is stock on 1250. Then here we have the default clock, it's 1050, and yeah, so we overclocked 65 megahertz. That's actually kind of good for the first start. Then here we have the second tab, it's sensors. So here you can check out your GPU core clock. GPU is not stressed, so it runs at only 400 megahertz. The memory clock, temperature and fan speed. Rest is not really interesting for us right now. Okay, then let's go. Let's run the benchmark. This is how Firmark looks like. It's an OpenGL benchmark. Now, if you have a multi-GPU system, so Crossfire for instance, then you have to think about how does OpenGL run on your system. Because, for instance, with Crossfire, and if you run something in OpenGL, it has to be in full screen, because in windowed mode, same also for some games, Crossfire is not activated. So make sure you tick the box full screen if you have a multi-GPU system. Unfortunately, I cannot do this right now because this would probably just crash my screen recorder. So I will just run it in windowed mode and 720p so you can see the rest here too. But you can just run it in the native resolution of your monitor and full screen. Okay, here we have multi-sampling. I will just keep it on off for now. Then if you want to run the GPU stress test, just hit this button here, GPU stress test, hit the OK button, and there you go. Okay, so what you can see in this window, it's a hairy donut or something like that. You'll probably hear the fan spinning up right now because you see in the chart here at the bottom, the GPU is heating up. And this hairy donut in the tube here, so this is actually a program which causes a lot of stress on your GPU. So there are a lot of calculations, and you see the GPU load is currently 100% here in GPU set, and you can also see it in the box in the left top corner in Firmark. So we have here a core clock of 1115 right now, and a memory clock of 1250. And yeah, now we should also check out the sensor in GPU set. So that is basically a real-time measuring of your GPU core clock. And here we can see that the average clock is currently 635. So that's basically the clock right now, and we can also check out minimum and maximum. And we just see that it's actually never reaching the 1115 we did set in MSI Afterburner. So there must be something wrong, right? And yes, we have the power limit at 0%, so we have to increase the power limit. Now the card is designed to drain, for instance, 150 watts at the maximum core clock. And if you do not increase the power limit, it cannot drain the additional power it needs for the overclock. So you definitely have to increase the power limit a little bit. So I will just increase it to 20%. Now let's see what we can get here. So here we have 1115, so this is right now. The sensor refreshes with a refresh rate of 1 second, 0.5 is okay too. And you can see this is really a constant core clock of 1115. Now, if you check out the benchmark, then you can see there are some lines across the screen. So what the fuck is that? That are artifacts. They tell you the overclock is not stable. You will also see that if you're in any 3D application, like if you're playing Battlefield and you don't want to see that shit. So now let me explain how to get rid of those artifacts. Usually you just have to increase the core voltage a little bit, and this will make the artifacts go away. Core voltage, it's dangerous. Now voltage can kill your device, so don't overvolt your GPU for no reason. So just increase the core voltage a little bit to achieve a stable overclock, like 10 millivolts. That would be a good step to do it. Okay, you can also enter numbers, by the way, by just clicking here at the number, then put them in with your keyboard. There we go, 10. Hit the enter button and then hit the apply button. Okay, so it's auto correcting it to 13. Well, now you see it's actually stable. We don't have any artifacts anymore. Oh yeah, there are some. So maybe we have to increase it a little bit more. 15. So it's actually always work in progress, try and fail. You just enter here some values. And there we go. Yeah, let's try 19, 20. Okay, there are still some lines on the screen, so a little bit more, 26. Okay, this looks stable so far, so actually I think 20, 25, that would be good. But more voltage causes more heat, so the card is heating up way faster. And you can see there's one problem with my card. It's already at the temperature limit. Like, we're currently reaching 87, 88, 90 degrees, and at 90 it starts to reduce the clock from 1115, if you check out GPU set, to 300, 400 just for 2 seconds. And immediately the temperature is dropping down to 85, and then the driver says, hey, the temperature is okay, we can go back to the full core clock. And you see it's going up and down, and you see the FPS, they are dropping. You can see the current FPS also here at the top, and we have FPS drops to 19 FPS, and that's thermal throttling. If you have that in the game, this absolutely sucks. So then your card is getting really hot, you're just playing, and then you just notice, hey, I only have 10 FPS for 2 or 3 seconds. And if you just see those FPS drops, then you should have a look at the temperature of your GPU. Maybe it's already too hot because the overclock is too high. But yeah, you can see we haven't overclocked a lot. It's already getting too high because the cooling solution in my computer is really kind of bad, and this is why I will switch to water cooling. Alright, but this should be an overclocking tutorial, so we just continue. Now only increase the core voltage so high that you can actually achieve a stable core overclock. The next thing which you want to do is you want to increase the memory clock. But we can quickly have a look here at that triangle, so you can usually click that and then you will get some more additional sliders like memory voltage and the aux voltage. The aux voltage, you usually don't have to adjust that because this is the PLL voltage of your card. It can help you a little bit to achieve a stable overclock, but usually you don't need to touch that. The memory voltage, it's unfortunately locked on the most cards. You see I cannot edit the slider here, so I can just play around with the core voltage. Okay, so the core, it's now stable, 1115. Unfortunately, we have the effect of thermal throttling. The next thing we're going to do is we play around with the memory clock. So in HardwareBot, so on HardwareBot, we could see that the maximum memory clock most people have achieved, it's around 1450, 1500, 1550. So from my experience with my system, I know 1450, it's stable, and we can just apply that core clock. Alright, so do you see any artifacts? No, I don't see any too. That means we don't have to play around with the voltage. We just check out here if we really run at 1450 here in GPU set. Okay, so it's constantly on 1450. And that means we don't have to play around with voltage. Okay, so the overclock is actually stable right now. The only bad thing is that you can see that line here, it's going up, down, up, down, up, down. So well, due to the temperature, I'm actually very limited. I cannot really overclock my system. You know, it's a multi-GPU system. Both cards are very close together. They are putting out a huge amount of heat, and that's the bad thing. So they're heating up each other, other components are heating up the cards too, and 90 degrees here, yeah, kind of bad. So that's the only bad thing with the R9 290 series, for instance here. They get really hot, and when they are really hot, then you have thermal throttling, which causes a lot of GPS drops. So well, let's go once again through the process of overclocking. First of all, you just start to increase the core clock a little bit. So just in small steps like 10-20 MHz, you always run a benchmark to see if it's stable. If you see any lines across the screen like artifacts, try to increase the core voltage a little bit, just that you can get a stable overclock with no lines across the screen, so no artifacts. And don't set the core voltage to +100, because this will just unnecessarily heat up your card and will probably cause thermal throttling. And the power limit, you can set it to whatever you want to. You can also set it to +50 if you want to, but I have just seen that sometimes increasing the power limit also caused some artifacts on the screen. Not really sure why, but it did. But honestly, the power limit, it's actually, if your card is draining 150 watts normally, so the TDP of your card is 150, and you set the power limit to +50, it could now drain 225 watts, so 50% more. So that shouldn't actually affect the clock or the voltage. But well, I would just set it to the maximum you need to achieve the clock. You see what happens if I set the power limit to minus, it will immediately clock down, because the graphics card actually is now restricted in power usage. Alright guys, so that's basically overclocking the core. Once you have done the core, just start to overclock the memory. Then also adjust the power limit if you need to, so if you don't get 1450, but usually the memory isn't really affected by the power limit, so the power consumed by the memory is not a lot. Main power gets wasted in the core of the GPU. Alright, once you found a stable core clock and memory clock and a voltage where your card doesn't heat up so much, you can actually save your overclock as a profile. I will just go back here to +20. And there we go. Let's say we want to save that overclock. We just hit here the save button, and then you can choose a profile number, like here, number 1. If you would want to go back to stock settings, you can do that by just clicking the revert button, and you see everything now is on default. And you can also save that to another profile if you want to. If you now want to load up the profile, just open up MSI Afterburner, hit 1 or 2, and you see profile is loaded and overclocked. You can also set MSI Afterburner as a startup program, but that is not good because, for instance, if your overclock is too high, you have to reset your computer, so restart it. Then it's always probably loading up MSI Afterburner and the profile. And that means you're always in some kind of boot loop because you reboot, then it's overclocking too high, it locks up your system, you reboot again, then you have to boot in safe mode, uninstall MSI Afterburner, just delete the config. Kinda annoying, so I would do it manually whenever you need the overclock. For sure, you can also underclock your card, so you could, for instance, just go below the stock clock if you want to save power, save that as another profile, so the possibilities, they're actually unlimited. You can also reduce the voltage a little bit then, and this should be completely stable. Alright, so we can see GPU is unfortunately running at 90 degrees, so that's the only bad thing. I also managed to get 95 with more voltage, and it was heating up so fast that it couldn't even throttle down so fast. And that's the only bad thing here in my system, so I will definitely have to go with water cooling because I want to bring you some really high overclock on the R9 290X, and I want to achieve some pretty good one with water cooling, but let's see what the future brings. So once you have stable clocks, run more benchmarks, run them in the maximum resolution your monitor can display, maybe with multi-sampling. Another good tool is actually Heaven Benchmark, and this is from Unigine. And yeah, it looks basically like Skyrim, so it's a virtual world, and you can set here some different quality, different DirectX mode, and I'm not really sure if I can run it because it actually runs in full screen if I'm right. No, we can run it in windowed mode, so let's try it here. And we choose here, for instance, 640. No, let's take 1280 times 720. And there we go. So basically Unigine, it's just a 3D world with a lot of effects, and this is also stressing your GPU. But this is better than Thermark because the environment, it's more like in a game. And also my GPUs are not heating up so much in here because they are not really running at maximum load. You can see right now they run at maximum load because of the effects, but also in some other games, for instance 4K Battlefield 4, they do not heat up so much like here in the benchmarks. But yeah, just run the benchmark here completely. I think it takes half an hour, 1 hour, I don't know. So you can also go around for yourself in the world. You have a lot of settings in here. And if you can see any slight artifacts, then just reduce the core clock. And also try to reduce the voltage then, or increase the voltage if you're not limited by the temperature, just like I am. Okay, you see right now 77 degrees, 81% fan speed, 100% load, so with that benchmark it's actually better, and I don't have thermal throttling here, and that's actually okay. Well, so I would just suggest that you run at least 1 or 2 benchmarks here, also in Thermark, and then just play some games. This is also really important because gaming, it's a little bit different than here in the Thermark benchmark, which is just putting unnecessary stress on your GPU. But if it's stable in Thermark, it will be also stable in the games for sure. So I will now just run GTA 5, but let's see if I can get it to work. It's not running on my system, probably due to Crossfire. Battlefield 4 and The Witcher 3. Witcher 3 in 4K only runs in medium details, and Battlefield 4 runs in 4K with ultra settings. So I will now just record some gameplay, and yeah, see you soon, just in a second. Alright guys, now I'm running currently a 3D Mark benchmark here on the first monitor, so in 4K. And well, on the second monitor here I'm monitoring the GPU, like the clock, if it's running at full clock, if it starts to throttle because it overheats, but basically you just have a look here at the GPU temperature. Maybe I haven't explained that too much, but you just hit up, so you run GPU set, and you go to the second tab, which is sensors. And here, the third one is the GPU temperature. So I'm currently monitoring this. This graphics card is a little bit more near to the CPU, so it's just changing the demo file. And it gets a little bit hotter than the other graphics card. So I just have a look at both, and they run with the same clock. And if one of them gets too high, so I just reduce the clock, because I don't want the graphics card is running too high, because this reduces the lifetime. So you just have a look at the cards, if they're running at the full GPU core clock as they should. Currently not, because the benchmark finished. And you also have a look at the GPU temperatures. If they get too high, reduce the clock. You don't want that your cards get too hot. That's really important, and that's my message in this overclocking tutorial. So don't always have a look at the performance, also have a look at the lifespan of your components, so don't let them run too hot. Okay guys, and then now let's just get over to the results and everything. So ladies and gentlemen, both R9 290X are overclocked, and let's have a look at the power consumption. Well, I'm draining now 750 watts out of the power socket. I'm currently in Battlefield 4, so I'm looking around, I'm shooting a little bit. And yeah, the power consumption is way higher than with the non-overclock cards. And we can have a look at the maximum I was able to draw from the socket. And have a look at that, 1020 watts. So a good power supply is really essential. You have some peaks sometimes, and if your power supply cannot supply those peak power, then your system will probably crash. And this is why I went with the Cooler Master CMV 1000. So it can output 1000 watts all the time, and also if you have some peak power over 1000, like 1200, no problem. The power supply can output it for a short amount of time. And that's a good thing. So my overclocking setup is totally stable. I gained a lot of FPS in The Witcher, also some FPS here in Battlefield 4 and 4K, and it's just great. Okay, then let's go to the computer and let's have a look at the results, and let me show you some charts and benchmarks. Alright guys, so now here on the computer, and let me quickly present you my overclocking results. So I did a 3D Mark benchmark test to see if the performance of the whole system has been improved, and yes, it improved a little bit. Then I did some gaming tests in GTA 5, Battlefield 4 and The Witcher 3. Well, I couldn't do GTA 5 because it was crashing all the time, and Crossfire seems to be an issue with the driver, but I have to get this fixed, and then I will bring you some gameplay probably next week. Okay, so let's have a quick look at the 3D Mark benchmarks, and here the first one. So this is without overclocking. Everything on stock clocks, and we can see I've got a score of 16,737, which is better than 98% of all results here. So well, here's the 4K gaming PC, which is a little bit faster. Now a 4K gaming PC is right now classified in 3D Mark as a Intel 4790K, so a slower CPU, but with the GTX 980 in SLI. So this is a better graphics card than the R9, but yeah, with overclock we can come to the same level, let's say it like this. Okay, let's have a look at the results with overclock. So here we go. And you can see I couldn't run all the benchmarks because it was also crashing. So you see multi-GPU systems, they are not so stable, and it's sometimes really a pain in the ass because things are not optimized for it. But in CloudGate, for instance, I could gain some additional 500 points. In Ice Storm, 1500 points or 1000 points. And you can see I outperformed here the 4K gaming PC. Now in other benchmarks, well, I get a lower score than this one here, and then I'm actually under it. But you see overclocking helped a little bit because I gained some additional score here in the benchmark. So the overall system performance has been improved a little bit. That's good. Then let's have a look at the gaming results. I played The Witcher 3 in 4K with medium details, more is not really playable. And yeah, with stock clocks on medium, I've got 33 FPS. And that's actually almost the limit where it's playable, because on high, I just get 25 FPS, which kind of sucks. Minimum 15 because there were some lag spikes, some micro stuttering also a little bit. And I've got here 935 in the menu, so forget the maximum FPS. Just have a look at the average FPS. Then here I've got 33 FPS average, and well, here also I was just for a short second in the menu. I didn't run this all the time to boost the average, but this was with the stable overclock, and I've gained here almost 30%, so 43 FPS average. And I can definitely tell you, I felt it. I just played, and it was way smoother than on the stock clock, so this helped a lot in 4K. But well, so I could also cheat because the maximum here just ran it for a longer time, but honestly I really didn't do this. I just had a look at the time. It was almost the same, so I didn't cheat on this, and the overclock really helped a lot to make The Witcher 3 playable. But on medium details, just keep that in mind. Then here we have The Witcher 3 in 1440p with ultra high settings. Looks ultra beautiful. I've got here an average of 27 FPS with overclock, and without overclock 22 average. You see the maximum is also a little bit higher, but I had some FPS drops, not sure why, to 8, just for a very short amount of time. I was in the same region, almost the same time, but well, I've got here some more FPS, so 5 FPS more, makes it almost playable, but here 22, well, with stock clocks wasn't so much fun. Then Battlefield 4, also in Battlefield 4 I've gained some additional performance. Those stock clocks I had average 51, then overclock too high, so that was actually throttling. Now the GPU got too hot, and then it just reduced the clock and the voltage, and then it just dropped to 48 or below sometimes, so that was the average. Minimum I had was 24, and you really felt it. It was sometimes lagging, then it was running fine, then it was too hot again, it did lag again. So the average was then also reduced to 48. Here we have unstable overclock. Here I got 55 FPS, so the minimum 32 increased a lot, as you can see. The maximum was actually, a little bit lower, but not really sure why, probably because multi-GPU system. I did run it with the clocks 1115, 1450, so that's a very slight overclock, and I just needed 10 to 20 millivolts plus to run this stable, which is a good thing. Then I did put all that into a chart, so you can see at one look that overclocking really improves your performance. Now The Witcher, 30%, and I would say it's actually 20 to 25 because probably of the menu here, which showed a lot of FPS, but I did run it several times, and it was always something between 20 to 25% improvement. So that's basically the most improvement I've got in 4K, because here the additional clock really helps a lot. 1440p also increased 22%, which is really good. You see very close to actually the 4K overclock, and here we have the overclock performance in Battlefield 4. Now that game is older, not so good optimized actually. I just gained here 8% improvement. Here some charts. So you see when the GPU did throttle, it was always a pretty low clock. Here it didn't throttle, so that was a good thing. But well, you see no OC, that's here in the middle. With OC stable, I've got some additional FPS, which is really good. And it's not always a linear curve, so it depends on the game, how good the game is optimized and whatever. So sometimes you overclock like 30% of the megahertz, and then you get only 5% in the game. Really depends on the game. You have to decide, is the additional power you drain from your power socket worth the 2 or 5 FPS you gain in the game? You really have to decide for yourself, because also keep in mind your computer is then draining more power, which also costs more money. Okay, so that's just regarding the performance in theory I've got, and now I want to show you some gameplay in Battlefield 4 and Witcher 3. Sorry, I'm a noob in Battlefield 4, I've just got it a couple of days ago, but I just want to show you how it looks in 4K, and after this you will hear my final conclusion about overclocking your GPU. And there we go, and now here in Battlefield 4 4K runs also really good without overclocking, but with overclocking you gain some additional FPS, so I usually have close to 60 FPS with overclocking, which is really super nice, because I currently run it in 4K on maximum, so ultra high settings. And okay, sorry, I'm a bit a noob in Battlefield 4, because most of the time I actually just play Counter-Strike Global Offensive, which is somehow, competitive, I really like it. Battlefield 4 sometimes gets really boring, I don't know why, but maybe I get used to this game because I just have this game here for a couple of days. But you see how nice that runs with Crossfire. You see, I'm a big noob. But it looks damn beautiful, so that game in 4K is probably one of the best shooters I've ever played, because really beautiful thing. And you don't even need two GTX 980 for this, so even the R9 290X runs it pretty nice. But as I've said before, with overclocking you gain some additional 5-6 FPS, which really helps you to almost achieve stable 60 frames per second. Okay guys, now that's it, I'm out, so that was the last gameplay for today. A lot of more gameplays are coming, and now let's come to my final conclusion about overclocking your GPU. Okay guys, so we're now here in The Witcher 3, and you'll probably hear the fans in the background. The GPU is currently running at 83 degrees, so yeah, when you overclock your system will get hotter for sure. Also this will cause the fans to spin up. I currently have 28 FPS, but I'm recording with reps in full size, so this causes a lot of FPS drop, but for some reason mirrorless action, which I bought, doesn't work for dual monitor systems with Crossfire and 4K. It has some real issues and crashes all the time. But you see, that game looks super awesome. It's 1440p right now, maxed out, and I really have a lot of fun with that game, even though it's currently really hard because I don't have the correct level for that enemy here. But there we go. You see, sometimes it's kinda laggy. I have some huge FPS drops right now to 20, and that's because, yeah, I'm currently recording here with full size, which is not really good. Oh, holy shit. But the message I actually want to tell you, if you're at 25 FPS just like I'm right now, and you want to get a stable frame rate like 30 to game, then a overclock can really help to achieve those 30 FPS. So usually it's easy to get out 4 to 5 FPS with a slight overclock. So on the most cards you can obtain that. Okay, let's die. I'm just too low for that shit. Oh, or maybe not. But if you're into The Witcher, I just bought it yesterday, and this game is really super awesome. The graphics, it's looking so nice. Have a look at the sun, the grass and everything. And this is 1440p, so not 4K, because in 4K I cannot play it at maximum. But even here at medium in 1440p, maxed out in 1440p, this looks really super awesome. In 4K I can only play with medium, but you don't need anti-aliasing anymore because it's really sharp. So yeah, Crossfire working, overclock working helps me to achieve here 30 FPS when I'm not recording, which is a good thing to make that game, for instance, playable maxed out. Alright everybody, we're now here at the end of this overclocking guide / review / info video. I just wanted to tell you what is overclocking, how can you do it, what can you get out of it. Now overclocking, I think you guys now know what it is, so you can get some performance out of your card for free. This affects for sure the temperature in your system, the stability, you need a good power supply, don't forget that, and it also just has an impact on your power bill, because if you drain more power from the socket, you'll have to pay more power on your bill. Now well, I managed to drain more than 120 watts for the whole OC, so that means it's 50 to 60 watts per card, and this is a lot just for overclocking. If you have the computer on 24/7, this would be 2.4 kilowatt hours per day or even more, and this is something like 50-60 cents a day. But well, you just have to decide for yourself. Also, just try it out. Probably nothing will happen, but please don't count me on that. So yeah, I never really overclocked the card so high that it broke down. But yeah, if it runs hot, then don't do it for a long time, because you know temperature affects all the components in your system. So also if the graphics card is just blowing out more hot air, this probably affects the CPU. So just keep an eye on all of that. If you change something in the system, you should also just check out what other components are affected by the things you have changed. Now you've seen you can gain some additional performance on the whole system in benchmarks. You can get definitely some improvements during gaming. The Witcher 3, it was really playable with the overclock. It was a huge surprise in 4K. Battlefield 4, some Well, some slight improvements, not so much, but it definitely gave me some boost, so up to 60 FPS, and this was rock solid with a slight overclock. For sure, those cards, they run quite hot, so I managed to get them over 90 degrees. Then I said that's too much, so only put up the voltage as high as you needed to achieve the clock. And if they run too high, then just forget the additional clock. Just go down. You want to have a cool system. You don't want to have something which heats up and probably damages your components on the long run. So don't overclock too high, have a lot of fun. If you're looking for graphics cards, check out XFX. I was very suspicious because XFX, I did read in the forums, well, bad cooling, they run really hot, blah blah blah, but honestly all other cards I've seen in the benchmarks, they run quite hot like this too. Fan is quite noisy because we have 4 fans, double dissipation in there, so you probably have heard my fans. This is also something which is affected, more heat, fans spin up, so just keep all that in mind and start with the core, then just go to the memory and only adjust the voltage as high as you need to achieve a stable overclock. Okay, ladies and gentlemen, so if you want to, then just go and overclock your graphics card, absolutely no problem. If you just do it like shown here in the guide, don't do too much, and if you see artifacts, if the computer hangs up, just reboot. Probably it will just reset and everything and nothing will happen. Okay, ladies and gentlemen, so thank you so much for having a look at this. By the way, this was my old graphics card, the GTX 970. We'll have a special video about it in the next days or next week, because I was very pissed about this card. Design is crap, 3.5 GB instead of 4, and some other crap which I will tell you in the next video. But thanks for watching, guys, have a nice day and bye bye, see ya.